Okay, here is another proof or another way of doing the sum of sines or the sum of cosines. Instead of changing the trig function, I am going to use the exact same trig function. I'm just going to change the angles inside, and I'm going to use the fact that sine is odd, which means if I stick a negative angle in there, it's exactly the same as the positive angle, but I'm going to multiply it by -1. Okay, so the first thing that we have to realize is that I can take any number. If I add two numbers, or let's say I subtract a negative number from another number, right? So those are just two numbers, 7 and 4. I can then change the sign of both of them, and it would make it positive. So this is saying that 7 plus 4 is exactly the same as 7 minus a -4. And you should know that from pre-algebra. That's the way numbers work. If you have two positive numbers, I can separate them into a positive number minus a negative number. So I'm going to use that fact to change this, because I cannot use the same definition to prove the postulate. So the first thing that I'm going to do is I'm going to change what's inside of here. So I'm going to say that this is the same thing as saying the sine of s minus a -t. And you might have alpha and beta there. So let me change this. Let me change this because I want to give you the exact same letters. So I'm going to prove that the sine of alpha plus beta is equal to the sine of alpha cosine of beta plus the cosine of alpha sine of beta. So again, I'm going to change the plus b to minus a -b, because those two things are exactly the same. So I'm going to rewrite this as the sine of alpha minus a -beta. And now, because I did that, I have the difference of signs instead of the sum of signs. See that? Now this goes from a minus sign to a plus sign. So now I can use the difference of signs definition. So I can say that the sine of alpha cosine of beta minus the cosine of alpha sine of beta. And I'm going to take this negative beta and I'm going to make this one negative, because that's the angle that I have, and I'm going to make this one negative because that's the angle that I have. Okay. Now I'm going to use the fact that the cosine of negative beta is equal to the cosine of beta, because that's even. And I'm going to use the fact that the sine of negative beta is equal to negative the sine of positive beta. Okay, so let's see what happens if I use this rule. This is the same as that. So that means that I can substitute this in for that. So the first part is going to change to the sine of alpha cosine of beta. So the negative sign goes away because that's even. And then I have minus, this is the cosine of alpha, and this one is the same as that one. So I can multiply this by a negative sine of beta. Now my angle went from negative to positive, but I had to multiply it by a -1. So I have this -1 there, and I have that negative sign there. So let me switch these two around so you can see it, because I can do that. I can switch the two trig functions around. So I can say that the sine of alpha cosine of beta minus a negative sine beta cosine alpha. I have a negative times a negative, which makes a plus, because those two things cancel one another. So then I get the sine of alpha cosine of beta plus the cosine of alpha sine of beta. And you see that this line is exactly the same as that line. If you use the properties of even and odd when you're doing the sum and difference of angles, it might be easier than using the pi over 2 minus theta that we were using before, because I'm still using exactly the same trig function instead of switching it around. And that's what I wanted to show you yesterday. So use the fact of odd and even in order to prove those postulates. All right, I hope that was helpful. Again, if you have any questions, please feel free to give me a call. All right.